I am going to teach you groundwater hydrology. Groundwater is a water below the surface of the earth in pores and fractures of the rock or soil. Groundwater hydrology is the science of occurrence, distribution, and movement of water below the surface of earth. Groundwater does not exist in massive underground rivers or lakes, with exception of some caves. Instead, it's primarily the result of hydrological cycle. When it rains or snow, melt water soak into the soil. Gravity pulls this water deeper through the pores in the soil and cracks in the rock. Eventually, the water reaches a depth where all the spaces in the rock and sediment are completely filled with water. This area is called the aquifer. The upper boundary of this saturated zone is known as the water table. It rises and falls depending on how much rain falls or how much water is pumped out. Importance of groundwater. Groundwater is vital important resources that support both human civilization and the natural environment. First important is lifeblood of agriculture. Groundwater provides nearly half of all water used for irrigation worldwide. Without it, global food security would collapse. As many breadbasket regions like Great Plains in the Ash are part of India do not have enough surface water to sustain large scale farming. Drinking water supply. For billions of people, groundwater is the only reliable source of clean water. Rural area often depends 100% on private wells. Unlike rivers that might dry up during a drought, aquifers react slowly to weather changes, providing a buffer during dry spells. Environmental health. Groundwater is what keeps water flowing even when it hasn't rained for weeks. This is called base flow. If it feeds wetlands and springs, which are critical habitat for many species. When groundwater is pumped out too quickly, the groundwater above can literally sink, damaging building and infrastructure. As water travels through layers of sand and rock, many impurities and pathogens are naturally filtered out. While it can still be contaminated by chemicals or runoff, it is often much cleaner than surface water found in ponds or streams. Current challenges. The biggest threat to groundwater is over abstraction, taking it out faster than the nature can put it back, and pollution from industrial chemicals or agricultural fertilizers because it moves slowly. Once an aquifer is contaminated, it can take decades or even centuries to clean itself. Classification of saturated formation. All earth materials from soils to rocks have pore spaces. These pores are completely saturated, but from the groundwater utilization aspects, only material through which water moves easily and hence can be extracted easily are significant. On the basis, the saturated formations are classified into four categories: aquifers, aquitard, aquiclode, aquifuge. Aquifer not only stores water but yields and transmit it in sufficient quantity. Example, it unconsolidated deposit of sand and gravel. Aquitard. Only seepage is possible and thus the yield it to well is insignificant. It is partly permeable through an aquitard appreciable quantities of water may leak to aquifer below. Example, sandy clay. Aquiclode. It is impermeable, contain large amount of water due to its high porosity, but are not capable of transmitting and supplying significant quantity. Example, clay. Aquifuge. Neither porous nor permeable and interconnected opening cannot transmit water. Example, massive compact rock without any fracture. Thank you.